All right. We have an exam today?
No.
A review for the exam. That's what it was. A review for the exam. Well, we're going to finish up graphing rational functions, do some more of that. And then I have a 10-question review. And last time I gave you the review and I said, have a nice day and see how you do. And it worked for some of you and it didn't work for others. So what I'm going to do today is I'm going to give you the review and I'm going to go through each of the problems one by one. So that's my plan, okay? And then what I would suggest you do is after I go through the review, I'll let you go, but to practice for a math test, a good thing would be to take the review out again, put away what you did in class, get out a cheat sheet, make your cheat sheet or whatever, and then practice testing environment, where you're sitting there trying to do it without anything to help you. And then as you need information, go ahead and go to your notes, go to the videos, whatever, and write down on your cheat sheet what it is you needed. And usually if you can prepare yourself by acting like you're testing, that's the best way to do it. If you just watch me do the answers and say, yeah, I got it, and never actually try it yourself, then it usually doesn't work out too well. So, if you're struggling, if you understand the material, then not such a big deal. All right, so rational functions. Any questions on homework? Can I see it? X squared minus 4 or x squared minus 1. Okay. I'm assuming it was f of x. It might have been something else. Right? This is it? Okay. So this is a rational function because you have a ratio of two polynomial functions. And since we have a rational function, we go through a long set of steps to graph it. So what was the first step? X-intercepts. So how do we find the x-intercepts? On the test, you're allowed to have a single sheet, right? 8.5 by 11 sheet of paper, front and back. Write down anything you want, steps, formulas, anything except
The answers.
except worked out problems. You can't just take the review and write down all the answers, okay? So I would write down the steps for sure. X-intercepts, how do we find the x-intercepts? Set the numerator, which I'll say n of x, equal to 0, and solve, right? That is definitely something I would write on my cheat sheet if I felt like I was going to get lost on graphing these things. All right, so we're going to set the numerator equal to 0. The numerator is x squared minus 4 equals 0. And there's really two ways we could solve this. One way we could solve it, okay, so one option would be to add 4 to both sides, like this. So adding 4 to both sides, and then take the square root on both sides. So if we take the square root on both sides, what do you always have to do when you take the square root on both sides of an equation? You have to do plus or minus. So the square root of x squared on the left is x. The square root of 4 is 2, and we have plus or minus. So that's two answers, right? Positive and negative 2. Right? Now, the other option would be to take your x squared minus 4, recognize that it's a difference of squares. So it would factor like this. Does that look familiar? Okay. And then once you have two things that are being multiplied to be 0, you set each one equal to 0. So I set x plus 2 equal to 0, solve that. X minus 2 equal to 0, solve that. So for this one, we subtract 2 on both sides. We get x is negative 2. We add 2 on both sides. X is 2. And so you get the same two answers that you did over there, right? Okay, so we have two x-intercepts. On our graph, these are going to be points that are on the x-axis, right? All right. So now we move on to the next step. What was the next step? Vertical asymptotes. How do you find vertical asymptotes? Set denominator equal to 0. So for the vertical asymptotes, you set the denominator equal to 0. This reminds me of what I'm doing right now. Reminds me of a professor I had in graduate school, Dr. Wilson. And he would write his notes so fast that we used to joke around that this is what it looked like. He would be writing, and he would be like erasing as he wrote. It was so fast. But we didn't have video back then, so we just had to scribble everything down real quick. All right, so set the denominator equal to 0. The denominator, x squared minus 1, is very similar to x squared minus 4, right? Difference of squares again. I have two different ways I can solve that. I'm going to go ahead and choose to do the difference of squares like this. And then set each one of those equal to 0. My two solutions will be 1 and -1. So I'm not going to show that work, but assume you can do that, right? Okay, is that fair? Okay, now these are points on my graph. What are these? Vertical asymptotes. These are these vertical dotted lines. They're like barriers. When my graph goes to them, can't cross them, right? So it forces my graph up or down when I get to them. All right. So that's the second step. Third step. Y-intercept? Is that what we had for third step? Yes. How do you find the y-intercept? Set the function equal to, plug in 0 to the function for x. So that's 0 minus 4 over 0 minus 1. That's -4 over -1. That's 4. So I have a y-intercept of 4. What is that on my graph? Y-intercept. So it's a point, right? And it lies on the y-axis. And I'll go up 4 and I'll draw a dot. All right. Next step. Horizontal asymptotes. So for the horizontal asymptotes, this is the one that I didn't get to show you all the different cases last class. That's why your homework only had the case that I had shown you, which was, well, what do? What do we do to find horizontals?
The coefficient divided by two leading coefficients divided by each other.
Okay, the two leading coefficients, which would be the 1 and 1 divided by each other. But you'll only do that when what? When the degrees are the same, okay? Don't make this mistake on the test because you will look at those numbers 1 and 1 only if these degrees are equal, okay? Last class I didn't show you if they weren't. So they are equal. So what I'm going to say here is that the degree of the numerator here is equal to the degree of the denominator. That makes sense? If that's true, okay, since that's true, it'll be the leading coefficient of the numerator divided by the leading coefficient of the denominator, which in this case is 1 over 1, which is 1. Now, this is a horizontal dotted line that we do not draw through the entire graph, right? We only draw it at the ends of our picture, and it serves as like a magnet, right? It attracts our function towards it at the ends. So this gives us our left and right hand behavior of our graph. What's the next step? Graph? Okay. So this is where things got a little weird. We will start with our standard x-axis, y-axis. And let's start with the things that we found in the first step, which were the x-intercepts. They were at 2 and -2, right? So I'm going to go out to 2. And it's an x-intercept, so it's on the x-axis. It's a point. At -2, it's a point. On your test, I will not give you, I don't think I will, I'm not going to give you a graph. It's just going to be a blank space on the page. That means you have to draw your own axes. All right. I've found that in the past it's a little better when I let you draw it rather than give you one. I don't know why, but it just seems to work that way. It's not for lines, which we already tested on. It's better if I provide the graph, but on this sort of thing, people do better with this. Okay, that all right? What's next? Second step, we found verticals. We're at 1 and -1, and those are dotted vertical lines. So I'm going to come in here. Remember, these dotted vertical lines at 1 and -1 are not technically part of the graph, right? They're just to help aid in my drawing of the graph. And also notice I did not put points here, right? I warned you about that. Do not put a point at the vertical asymptotes because you will think later when you're trying to draw it that that point's on your graph. In fact, there is no point there. It's a vertical asymptote. No point, your graph's not allowed to go over there. Next. The y-intercept, right? Y-intercept, which was at 4, 1, 2, 3, 4. So I put a dot there, right? And then I put my last piece of information, which was the horizontal asymptote, and that was at y equals 1. So here's y equals 1, right? I'm going to draw a horizontal dotted line, but only at the ends. So what I mean by the ends is if I move to the left here, I have a vertical asymptote, and then I have an x-intercept. After that, I don't have anything, right? So after I get past the last piece of information is when I'm going to draw my dotted line. Just somewhere over here, dotted line like that. And then over here, somewhere past 2, dotted line like this. Okay? All right. Now we try and draw it. And when we try and draw this, we're going to read it like a book from left to right. And I'm going to go to the first point that I actually know exists on my graph. So what's the first point that I know exists on my graph as I look from left to right? At -2, I have an x-intercept, right? So imagine now from -2, if I have my pencil here, I have to draw it to the left and to the right. So if I draw it to the left, right, what has to happen? Where do I have to go? Up to where? Like up here? That dotted line says that's where I need to go, right? That I'm supposed to get pulled towards that. So I'm going to just draw it like this and then just draw an arrow like that to represent the fact that I'm getting closer to it without actually ever getting there. Now a tricky part. I have this point here and I need to try and draw it to the right. Now I have a vertical asymptote that's in my way, right? So I know I'm going to be forced either down or up, right? But if I draw it and I go down like this, is that okay? Does it seem like that would be okay to do that?
Yeah.
Yes? Now what if I bounced off and came back up? Would that be okay? If I just bounced off? Would I be breaking any rule here? Look, if I draw like this, bounce off and go up. Is that wrong? By looking at this, is it wrong? It looks wrong, yeah. Okay, I'm glad you said that. Notice I always say draw your horizontal at the ends, right? The reason why is because students who will draw them all the way through will think you can't cross them, but you actually can cross. Horizontals only tell you end behavior. They don't tell you anything about in here. Okay, so it is technically actually okay to do this, but it would also technically be okay to do that. Would it be technically okay to do this? Come down and then back up. That definitely couldn't happen. Why? Because I created an x-intercept. Okay, so here's where I'm at. I've got basically one of two possibilities that could happen, right? So what do? We just get out a coin, we flip it, heads or tails, up or down, right? No, there's a way we can do it. What did I say we do when we don't really know what's happening somewhere? Just test a point, right? Now, what I need to do is test a point between these two, right? Anything I can think of in between here and here. So what's a good point between here and here? -1.5, right? -1.5. So I'm going to draw a little X there, and then over here on the side, I'm going to say test point. So my first test point, I might have to do a few here on this problem. My first test point is trying to plug negative 1.5 into the function. Does this make sense to everyone what I'm doing? Okay. Plugging it into the function means I have to do negative 1.5 squared minus 4 over negative 1.5 squared minus 1. That was it was x squared minus 4 over x squared minus 1, right? And I'm replacing x with negative 1.5. So you get on your calculator, right? Negative 1.5 squared gives you what? Then you subtract 4, right? And you should get a negative number. And then on the bottom, 1.5 you square it and subtract 1, you should get a positive number. Do y'all want to know what these values are, or can you plug those in yourself? Everyone bring their calculator, right, to the test? Not your phone? So what you get is on the top a negative, on the bottom you get a positive. What's a negative divided by a positive? It's going to be negative. Now, I don't really care about the value. Now, if you want the exact value, I'll tell you what the exact value would be. If you do the computation on top, you get negative 1.75. And then on the bottom, you get 1.25. So that's what you would get if you did those computations. Then you divide those, and you get negative 1.4. Is that clear? Now, I said I don't care what the exact value is. All I care about is that it's negative. Why do I care that it's negative? If it's negative, then that means I'm going to put a point down, right? At negative 1.5, I put a point somewhere down here. So it can't be that top one, can it? So I'll just throw a point down here like that. And then I'll get this one out of here. Now, let me kind of back up. Here's where we were. We didn't really know what was happening here. We tested a point. It came out to be negative. Since it's negative, now I have to go from that point to this point, and that forces me to have to keep going down. Why? Because I can't turn back up because I would cross the x-axis. Is that clear? Process of elimination, kind of. No questions? Yes?
For the exam, do you want us to put a test point? Is that required?
How else would you do it?
Mentally do it, like if you want to.
You mean
see
like
us-
mentally plug it in?
Yeah.
At least tell me, like, I tested a point. So I know it wasn't just like a random guess. Because most people would look at this and they would say it looks like it's going to go down. But that's not good enough because I could give you a function that would bounce here. And bounce off. I could create a function that would do that.
I just want to make sure.
Yeah. So as long as I know what you're testing, if you just wrote down test points and you just wrote down like that, and then put something like, okay, that's negative, or, you know, then I know you did it on your calculator or whatever. Okay, once we get to this picture, this part being drawn, we have to keep drawing our picture to the right. Now, there's a vertical in my way, so I kind of have to jump over it, pick my pencil up, and I have to find the next point that I know exists on my graph. Well, that one right there, right? So if I look at this point right here, and I imagine I have to draw it out this way to the left and to the right. If I try and draw it to the left, it's going to run into the vertical. The vertical has to force me down, or it has to force me up. Which way does it have to go here? Up. Why not down? If I go down here, I'm going to eventually cross the x-axis, right? What about this side? It's got to go up. Because again, if I go down, it'll cross the x-axis. Could it do this and not cross the x-axis at all? Why not? It wouldn't be a function. Wouldn't be a function. And I made a y-intercept that didn't exist. But more importantly, it fails the vertical line test. So that isn't even a function. So you can't wrap back around yourself like that, even though that would be a kind of cool picture. All right. So to the left, I have to go up. To the right, I have to go up. So I'm going to draw it like this. I'll extend my dots like that. Like that. So it looks like a little parabola in there. And then I have my vertical in the way. I jump over. My next point that I know for sure is this one. To the left, I don't know. Could I go up? Could I just go like that? Could I go from here and go down? Yes. So what do you think it's going to take for us to determine that? Another test point, right? What about going this way? I have to go up to this, right? So I know this has to happen. That has to happen for sure. Now, if I'm going to have to determine if it goes up or down here, I'll test the point. What's a good point in there? 1.5. If you plug 1.5 in, wouldn't you get the exact same thing as plugging negative 1.5 in? Because remember in the formula you squared it? That was the first thing you did? You squared it and then subtract 4, and then you divide that by x squared minus 1. So when you square negative 1.5 and square 1.5, you get the exact same numbers. So this would actually come out to be negative 1.4 again. Which means that at this point, I have to go down, draw a dot, and then now that's enough information for me to know for sure it does this. That's your graph. Okay? Any other questions on the homework? Okay. All right, so everything that I've given you up to this point has turned out to be, with the horizontal asymptote, it's always been where we looked at those leading coefficients, right? And we want to try something a little different. All right, so let's do this. Okay, let's sketch f of x equals x squared plus 2x minus 15 over x cubed let's make it 2x cubed minus 12x squared. Now we're talking. We have a polynomial divided by a polynomial. It's a rational function. First step is to find the x-intercepts. So to do that, I will set the what to what? Numerator to 0. You can say it in your sleep, right? No. What's that movie, Kill Bill? Where she wakes up and she's like punching still, right? You don't wake up and start spelling out the steps to rational function, sketching. Wow, okay. What do we do with that? Factor it, right? Factor it. This is a quadratic, and I'm trying to figure out when it's 0. So if I can break it down into 2 factors, I can set each factor to 0. So I'll use AC method here. My AC, what? Oh, what's wrong? Oh, okay. I said, oh my God. I'm going through all the steps because we have a test next class. I want to make sure I don't skip anything. That's what I would do, right? Then I come up with 2 numbers and multiply to be negative 15, add to be 2, which are 5 and negative 3, right? And then if you follow what I did before, I said bring the ends down. Let's see, bring down the negative 15. In the middle, we rewrite the positive 2x as 5x using this 5, and then minus 3x using that negative 3. And then I'm going to say still equals 0. And then we have 4 terms now. We split this. We do GCF out of the first two, which is x, left with x plus 5. What do we do out of the second one to make this work? We do x plus 5 here, which means we need a what there? -3. And it works. Right? So now we have x plus 5 times x minus 2. I think it's safe to say that on your first test, that could have been a problem by itself, right? That would have been one problem on the test. Now you see it's only one step of one big problem, right? That's why we try and tell our developmental students, you've got to be able to factor, you've got to be able to solve quadratics because you need it a lot in college algebra. All right, so now set each of those equal to 0. What do you get? -5 and +3. 2 x-intercepts. Are y'all having a good summer? Y'all enjoying your summer? I mean, not like this part of it, I guess, but doesn't seem as hot this year,
It seemed
right?
like it just started.
Does it? I can't wait for it to be over.
Is that, my pool wasn't ready to use until like the end of June.
Yeah?
It just wasn't warm enough.
You should do a pool warmer. Have you ever thought of that? Pool warmer?
I mean, I have a heater, but it's
Like a-
costing.
Yeah, I know. It's, I'm sorry, everyone, but this is important. What I did is I bought the, you know, the landscaping black tubing that you use for landscape irrigation?
Yeah.
You can buy the 500-foot rolls of it for like $40, and you just build a little contraption, you coil it, and you put it like on the roof of your shed or whatever you might have in the backyard, and you run a couple of those coils, and then you run your pump through it, and you can heat it up like usually about 3 degrees a day. So what is it, July? I think we were swimming like early May. Yeah. As long as there's sun, you can heat your pool.
I'm not in winter.
You have to have sun, and if it gets too cold, you know, then you have to go with the real heater. But it's pretty efficient. All right, what now? Vertical. Vertical. Does your pool ever get too hot?
My wife will never say that it gets too hot.
I hear you on that one.
I think right now it's about 90 degrees.
Oh my goodness.
I think it feels awesome, especially at night.
Yeah, it's good for night swimming. But
Yeah.
okay, so for verticals, I set the denominator to 0. We'll talk pools later. I've got a pool cooler that works reverse effect, and you can cool the pool down like from 90. If it's 90 at the end of the day, you can cool it down to like 83 by the morning, and then it heats up during the day, and you do it again the next night. But we'll talk later. Okay, vertical asymptote. There it is. Set the bottom to 0. What the hell's that? How do we find when that's 0? What did we do in the last problem? We factored using AC method. Why did we do that? Because it looked like quadratic, right? But let's get back to factoring again. First step is always GCF. Do you have a GCF here?
2x squared.
2x squared. Okay, let's try that. If I take 2x squared out, I'm left with x minus 6. Is that correct? And what we've done is we've created two things that multiply to be 0. If two things multiply to be 0, one of them has to be 0, so you set them both equal to 0. So I'm going to set 2x squared equal to 0, and I'm going to set x minus 6 equal to 0. So I'll do that one as easier. X is 6, right? Add 6 to both sides. On the other one, people sometimes get a little bit confused with this one. They want to say, like, I don't know, the answer is -2, or sometimes they'll say it's 1, or I don't know. I don't know what people think sometimes, but I want to get x by itself, right? So I'm going to divide both sides by 2. 0 divided by 2 is still 0. And what's the only number that when you square it, you get 0? 0 itself, right? 0 times 0 is 0. So there's only one solution here, 0. You don't have to divide by 2. I'm just trying to show you that the 2 doesn't matter. At 2x squared equals 0, if you just say x is 0, I'm happy. All right? Little side note here, and this won't be on video, but what if I had this? 2x minus 12 equals 0. And I factor GCF out. What if I did? I get 2x minus 6 equals 0, wouldn't I? What are the solutions or solution to that?
6.
So these two things multiply to be 0, right? So you set them each equal to 0. This one is 6. What about that one? 2 is not 0, right? That 2 has no effect. So basically, the 2 doesn't give you an answer. 2 can't be 0. Another thing you could have done to convince yourself this is the only answer is up here, you could have just divided by 2, right? Or if you back up here, move the 12 over, divide by 2, and you get 6. That's your only answer. But I'm just trying to show you that the only reason we got a 0 here is because we had an x out here. If it was just a number out here, then you can throw it away. It won't factor in. All right, these are vertical lines. I've got 2 of them. Next, y-intercept. Okay, so to do that, I plug 0 into the function. Let's see, 0 squared plus 2 times 0 minus 15 over 2 times 0 cubed, right? Minus 12 times 0 squared. That gives me negative 15 over what? Whoa, wait a minute. Negative 15 divided by 0 is undefined, right?
Yeah.
What's going on here? There is no y-intercept. Why is that? Think about the vertical asymptote. Where were our vertical asymptotes? Let me erase this because this wasn't. They were at 0 and at 6, right? So through 0, I have a dotted line, which means I can't possibly have a y-intercept, right? So that makes sense that I have none. None? That doesn't seem right. I have none y-intercept. I have no y-intercept, right? Okay. Fourth step. So here's where things are a little different on this problem. For the fourth step, which is horizontal asymptotes, I look at the degree of the numerator. What's the degree of the numerator? 2. I'm going to call it n, all right? And then the degree of the denominator, I'm going to call it d. What's that? 3. So the relationship I have is that the numerator is less than the denominator. Do you agree? They're not the same. They're not equal. Now, if you look back in your notes from last class, I told you there were 3 possibilities, right? They could be the same. The numerator could be smaller than the denominator, or the numerator could be bigger than the denominator. I called that trichotomy. Only 3 possibilities. And what happens if you look back in your notes when the numerator is smaller than the denominator? I can't say that. Numerator smaller than denominator. What is it? Y equals 0. So what you should do is on your cheat sheet, you should make sure you have all 3 of those cases written down so you don't forget them. All right. What's y equals 0? On a graph, what's y equals 0? The x-axis, right? Right, y equals 1, 2, 3, 4, y equals negative 1, negative 2, negative 3, negative 4. Y equals 0 means don't go up and down. So it's a horizontal dotted line like this, only drawn out at the edges. It's like the x-axis, but only at the edges. All right. Picture time. I really am tempted to turn on that game, but I'm not going to. Yeah. I know, it's kind of a bummer for some of you, but. What do I start with?
X-intercept,
X-intercepts, what were they?
negative 5, 3.
-5 and 3, so 1, 2, 3. What am I going to put here? Dotted line? Just point right there. And then -5? Dot. Okay? Vertical asymptotes.
6 and
6 and 0. Let me do the 6 first. 4, 5, here's 6. It's a dotted vertical line. And over here at 0, right?
0.
Now, how do I draw a dotted line on top of my solid line? That's those little diagonals that I showed you can do. Anything that helps you remember that you cannot cross that. Next piece of information, y-intercept. I didn't have one. Last one, horizontal, which was what? Y equals 0, which is my x-axis, right? Now, on the left side, my x-axis, I need to start drawing a dotted line once I get past this point. So I'm going to erase some of this, just because I don't want to go off camera. And just start my dotted line here. And then on this side, right after the 6, start my dotted line here. Now, we have to try and figure things out. The first point that I know exists on my graph is this one, right? And where am I supposed to go to as I go to the left? Towards that dotted line, right? But I can't just stay flat, okay? Why can't I just stay flat on the x-axis like that? What's that? Because the only place I'm allowed to touch the x-axis is here and here, right? That's it. So if I were to just be flat the whole time, then every single point there would be an x-intercept. But I only have one. So I can't be on the x-axis. That means I either have to be above it or below it, right? And then what happens is over time, I start getting pulled back towards that dotted line. So I could do it that way, or I could go and do it that way, right? Either way would be okay. Which way is it?
The top one.
Why? Flip. Top. What are you going to need? A test point. It's the only way to know for sure. So I'm going to have to pick a test point right here. And it can be any point, any number, this over here, anything. You can pick -6. You can pick -10. You can pick -30. Doesn't matter. Anything to the left. Okay, so I'm going to pick -6. So I'm going to test -6. F of -6. Ooh. I have to plug that into the thing, don't I? -6 squared plus 2 times -6 minus 15 over 2 times -6 cubed minus 12 times -6 squared. Isn't that what I'm supposed to compute? Yes? Isn't that somewhat of a disaster waiting to happen? I mean, you could do it, right? Maybe? I would like to show you another option that's faster. You want to see another option? Didn't we say all that matters is if it turns out to be positive or negative? It'll tell me up or down? Yes? Watch this. I'm going to rewrite the original function. But didn't we factor the numerator? Didn't we factor it to be x plus 6 times, no, sorry, x plus 5, x minus 3? Isn't that how we factored the numerator? Yes? And didn't we factor the denominator to be 2x squared times x minus 6? Isn't that what we did? Okay, I have multiplication here and multiplication here, don't I? Okay, watch how fast I'm going to be able to figure out what's happening with -6. See, with this, you have to get on your calculator, square that, you get 36, do that, -12 minus 15. Then you have to cube -6, you have to square -6, put it all together and get an answer, right? But watch how quickly it'll work with this instead. What's -6 plus 5? -1. But do you agree it's just a negative number?
Yeah.
Okay, so I have a negative number top left. Then I'm going to say multiplied by, what's negative 6 minus 5? Sorry, I should change that to negative 6. What's negative 6 minus, sorry, what did I say 5? Negative 6 minus 3. Negative 9. It's negative there, right? Okay, over, what's negative 6 squared times 2? It's positive, right? It's a positive number. Okay, and then times bottom right corner, negative 6 minus 6, negative 12. That's a negative number. Two negatives on top multiplied would be a what? Positive, and then a positive and negative on the bottom? Negative. Positive divided by negative is negative. So I know it's down. It's on the bottom. You've already done the work to factor, right? Now you may think, oh, I don't want to do that. But wait, we might have more test points. And I assure you that if you want to stick to the other way, I will definitely beat you to the answer every time. Right? So let's see. I'm going to come back over here, and I'm going to draw the one on the bottom, right? Because this gave me a negative value. So I know I'm down like that. Okay, now I have to draw this to the right, and I have a vertical in my way. Could I just go like this and go up like that and keep going up? Just like that? Yes? Could I have bounced off and came back down? Yes? Yes. I could have. So you have to do another test point. The test points turn out to be one of the most tedious parts of these problems. Now, give me a test point in here. Negative 2. Okay? Right there. Negative 2. So now what I'm going to do is I'm going to test negative 2. I'm going to do it right here. F of negative 2. Watch how quickly I do this. It's going to go right into this. Negative 2 plus 5? 3, right? Positive. Times. Negative 2 minus 3? Negative 5. Okay? Negative 2 squared doesn't matter. Times 2 is positive, right? Bottom right, negative 2 minus 6? Negative 8. The top is negative. The bottom is negative. Negative over negative is positive. So it is positive, which means it's somewhere up here, right? So what I'm going to do is I'm going to draw my graph this way like that. I don't care what the value is. I really don't care. I just care that it went up and it didn't bounce and come back down. Questions on that? Yes?
Could we do the same bounce cross method from the last graph? Like if it's
Excellent question.
even enough?
Excellent question. It's a little trickier because you have to take into account what's happening down here. So you can't just look at, like I think you were saying, the power up here, because this is negative 5, it came from that one, right? And because that's a 1, it says cross. The issue is that these can affect it also. So it's not as simple as that, unfortunately. If it was, I would tell you, I'd give you that method. But there's just too many other things that play into it. Let's do the next point. So here's our next point that we know for sure, right? To the left, I have a vertical, so I'm going to have to go up or down. Which one? Do I know? Up or down? Do I know just by looking? No, I don't. It could go up, it could go down. So I'm going to have to test another point. So I have a test here. Let me test 1. If I plug 1 in, what do I get? Let's see. So if I test 1, 1 plus 5 is 6. That's positive. 1 minus 3 is negative 2. This is always positive, isn't it? And then this, 1 minus 6, negative 5. So what does that give me? Positive. So that means over here, I have a point up, right? Which means it's going to go up like that. Now, I don't know if anyone was thinking, I don't know if anyone had thought this yet. Our first test point was negative, wasn't it? Our second test point was positive. How many of you were thinking this one was going to be negative and they were going to alternate and you're going to be all happy about it? Because a lot of times I'll give examples and they will alternate. People will be like, oh, will they always alternate? Because if so, then I just find the first one, then I know everything just switches after that. This is a good example of the answer is no to that, right? It looked like it might alternate, negative, positive, negative, but this one turned out to be positive. So we have to test the points. All right, what about drawing it to the right? It could do this, Or it could do this, right? So again, another test point. 4. So I'm going to plug 4 in. F of 4, I'm running out of room over here. F of 4, plugging it in here, what do we have? Positive. Positive. Bottom left is always positive. Negative. A positive over a negative is negative. So I know that this point at 4 was down, so that means this graph went like that. We're almost done. Now I come over here. I don't have any points. Right? So I should get one. How can I get one? Test a point, right? 7. So I'm testing 7 now. I test 7. I erased the part that I needed, but it was positive, 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 positive. All positive. Is it good to test positive? Depends on what you're being tested for, right? Okay, okay, so positive, right? What does that tell me? Is that enough to finish this graph off?
Yeah.
To the left, what happens? Barrier forces me either down or up. Can't go down because I'll cross the x-axis, right? So I have to go up. So I'm going to go up like that. And then when I come this way, what has to happen? Get pulled to the magnet thing, right? So the thing's going to look like this. It's going to pull down here. Over here, it's going to go up. We are done. Took a while, right?
Why do you start so high?
I didn't have to. Yeah. If you draw yours and you put yours here and you do this, it's not going to be wrong. That's right. It does not have to be accurate. The point when you say this is negative, it's we don't care about how far it is. All I know is that if it's negative, the graph is completely different than if it's positive. Now, remember with polynomials when we were graphing those, we had crossing and bouncing and left and right behavior. Remember all that? I said just come down and come up and you bounce and bounce. Who knows what? I said we don't know how low it goes. We can't find those. You have to do calculus to do that. Same with this. If you want to know how low this goes, you're going to need to use calculus to get that value. So we just kind of wave our hands at it. Okay. What's your feeling on these? I think I said in the beginning of the semester that the rational functions are the most challenging functions to graph. Do y'all feel like it's doable?
Yeah.
Doable? Okay. All right. I'm going to give you one more example before we start talking review. On the example that I'm going to give you now, I have not given you that third case, right? We've seen cases where the degrees are the same, and that's when we looked at the leading coefficients. We've just seen a case where the degree of the bottom is bigger than the top, which the x-axis was our horizontal. We have not seen what happens when the top degree is bigger than the bottom. So let's take a look at that. So would you like ugly or would you like not ugly here? Not ugly? Comparable to test, right? Okay. Then really ugly. No. There. This one's pretty basic. It's just to make the point that I'm trying to make about the degrees here. So first step, x-intercepts. Set top equal to 0. That one pretty clean. What's the only number you can cube and get 0? 0 itself. Okay. Second step, verticals. Bottom equal to 0. You can difference of squares. X plus 3, x minus 3. You get two answers, -3 and +3. Third step, y-intercept. Set the function to 0. I keep saying that. Put 0 in the function. What do you get? 0 over -9, is that okay? It's okay to have 0 on top, right? Okay, so that's just 0. That's our y-intercept. And then finally, our horizontal. So this is the part that's going to be a little different. What's the degree of the numerator? Degree of the denominator? 2. Numerator's degree is bigger than denominator's. What happens in this case? There's no horizontals, right? Now, I did not mention this in your notes, so I'm going to mention it now for the first time. When you do not have a horizontal, that means you do not have a magnet pulling anything down towards it, which means it's going to behave like a polynomial. Remember polynomial left and right behaviors? Polynomial was either this, 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 or this, right? When you don't have a horizontal asymptote, you are going to have at the ends either this, this, or on this side you're going to have this or this. All right, so what I'm going to do here is I'm going to put this or this for the left. In the middle is going to be a bunch of crap. It's going to be whatever's happening with our vertical dotted lines. But on the right, it's going to be this or this. How do you think we're going to determine which one it is? Test points. But maybe we won't need them. We'll see. It'll just depend on the problem. All right. Let's do it. Graph. Starting out with my x-intercepts. X-intercept, I only had one, right? 0. My verticals were at 3 and -3. Horizontal, or wait, y-intercept, right? I already have my y-intercept. Horizontal? None. I'm really thirsty. I'm going to go get some water. Why don't you try and draw this? You're obviously going to need some test points, right? Do you know anything about what's happening over here? You just know it has to go up or down, right? Like this? You know nothing, so how are you going to get something over here? Test something there. How about between these two right here? Like, do you know from this point if you go up, because the vertical is going to force you up or down. Do you know if you go up or down? You don't, do you? Test. And then here, do you know if you go up or down? No. Test. Then over here, you don't know anything. Test. So you've got what, 4 or 5 test points? 4. Go ahead. I'll be back. Remember, if you're going to do the test points, I would recommend you plug them into your function. I'm just saying this is the way I would do it. You don't have to. But that's our function with the bottom factored. And so you can do whatever your test point is cubed to determine if it's positive or negative, whatever your test point is here, whatever your test point is here. So those will be either positives or negatives or whatever. You just put it all together. If you get your picture, let me see. You raise your hand, I'll come and take a look. You got a picture? That's what you got. Okay, so I agree with the middle, but think about the ends a little bit. Okay, so you got positive here? Okay, so I said the left has got to go up or down. It's obviously got to go up because it's not go down, right? But what about this? What's this going to do?
Okay.
Let me see. Just draw a point first. Just put a point. Put a point like this. It's positive, right? That way, what has to happen? Goes up, right? And then this way, what has to happen?
Okay.
See? You were just missing that. There you go.
Yeah, so
There you go. That's it. Yep. Anyone else got a picture? Good. Okay, what about in here? Did you test anything in here? The one. So what did you test? You do just a mental into this? Okay, so let's just try one. 1 cubed is 1. 1 squared is 1. 1 minus 9 is negative. 1 over negative 8. See what I'm saying? Down, that's out. What about negative 1? Did you test negative 1?
I probably remember.
So try negative 1. What's negative 1 cubed? Negative 1. Negative 1 squared is 1. Yeah, you need to check negative 1 there. Yeah, the outside's good. Yeah, oh wait, hold on. Are they flattening now? You can't flatten. Because you don't, remember, we don't have a horizontal? Okay, so you're correct that it goes up like that, but when you're going this way, don't go flatten out. Do one of those. Which one does it have to be? The left. Nope. Up. So yours is going to look like this, and then it comes back, and it goes up. Yeah. All you have to do is curl that up. There you go. That's it. Okay? Yeah, good. That's it. Anyone else had it yet? That's good on the left side. Good. Okay, yep. Now test your, what, negative 1? Negative 2? What are you testing? I'm not going to put the game on, I'm just going to put the scoreboard on. Is that all right with everyone? I'm going to go through this problem in a second, but I want to see how you do on your own. Or with the help of your table. Who needs help? Anyone? What's going on over there? Test point? How about over here? What's the test point you can use here?
I put negative 4.
Okay. What did you get when you put negative 4 in?
Well, minus positive.
Negative, anything cubed, right? Negative, negative, negative will stay negative,
Oh,
right?
no. What would this be?
That would be negative also. So opposite signs, just they're the same sign, you multiply same signs, you get positive. You multiply different signs, you get negative. Okay? Okay, getting close. You don't have a vertical axis. Right? This is not a vertical. So you picked a test point here, right? You got positive. Did you do -2 or -1?
Negative.
-1. So you got a positive. You plugged in 1, you got a negative. Okay. So if I go from this point this way, I agree you have to come up like this. But you do not have to turn up here because this is not a barrier. This is just your y-axis, but you have to get to there. So it's got to go like this, and then you got to get to there. And then this vertical is going to force you down. Okay? I'm going to go through this, all right? All right, so look, the test points that I would have used, I would have picked something over here like -4. I would have picked something like -1 or -2. I would have picked 1. And I would have picked 4. That way I could determine what's happening in each of those regions. If I plug -4 in here, I have -4 cubed. What's a negative times a negative times a negative? Negative number? Over -4 plus 3 is negative. -4 minus 3 is negative also. Negative divided by negative, or sorry, negative times negative, positive. Wait, hold on, what the hell? All right? I was telling people their answers were right, but now...
I'm right. It goes down.
Well, that's right. Hold on. Negative times negative times negative, right? It's going to be negative. -4 plus 3 is what? -1. So that's negative. -4 minus 3 is -7. That's still negative. 2 negatives multiply to be positive, and then this is negative. So the ratio, negative divided by positive, is the same as multiplication. If they're different signs, it's negative. So that should be a negative number. Uh-oh. All right. So that's a negative number. Let me do all the test points. If I test -1 now, what's -1 cubed? Negative number. What's -1 plus 3? Positive. What's -1 minus 3? -4, so that's negative. The bottom is a negative number. Top is negative. What's negative divided by negative? It's going to be positive. So at -1, you're positive up here. It's okay? +1? What happens if we do +1? What's +1 cubed? 1, that's positive. What's +1 plus 3? Positive. What's +1 minus 3? -2. So we have a positive over a negative, which is negative. So at 1, I have a negative point down. And then what happens if we plug in 4? On top, 4 cubed is a positive number. 4 plus 3 is 7, so positive, and then 4 minus 3 is still +1. So positive over positives is all positive, right? So we get like this. Y'all okay with that? Test points? All right, I'm going to erase my labels there to try and take some of this junk out of here. From that, I should be able to draw the picture. So let's look at this point on the left-hand side. If I'm going to draw this to the left with my pencil, I have no horizontal, so no magnet. So it's got to either be going up or down. I can't go up, why? Across the x-axis, so I have to go down from there. So from here, I have to go down, like that. Now, if I draw it to the right, what has to happen? Well, the vertical is going to block me, right? So I have to go up or I have to go down. I cannot go up, right?
Yeah.
Because I'll cross, so I have to go down, so it turns back and goes down like that. So that's what it looks like. Now I jump over the vertical, I go to the next point that I know of, which is this one. To the left, what has to happen? Well, either up or down, right? Can't go down because I'll cross, so it has to go up. And then as I draw to the right, what has to happen? I have to get here, right? And then as I keep going to the right, I have to get here. So like between here and here, we're in kindergarten, aren't we? We're just connecting these dots right here. But then once we get past this, we're like, where do we go? Where do we go? Here's our vertical. It's going to force us up or down. Can't go up, so I have to go down. So it's going to be going up, connecting, and coming down. So I'm going to draw it all together now. Up, connect, down. And then the last point, to the left, I must go up. To the right, because I have no magnet, it has to go up or down. Can't go down, so it has to go up. So it's going to go up like that. And then this way, it's got to go up like that. That's what it should look like. Make sense? What is the thing I told you to do after you draw the whole thing? One thing to check real quick. Vertical line test, right? Just make sure that as you draw, don't actually draw a vertical line, just mentally do it. That you're not hitting your graph in more than one place. You know? You should only intersect your graph at one point each time you do that. So that is a function. Okay.
You gotta refresh it.
Well, if I have to refresh it, that kind of defeats the purpose. I thought it was going to automatically do that. You know what it might be? It might be this little lightning. Oh man, is it going to be the video? I don't want the video.
Might just be a commercial.
Heck, no. Stats? Maybe the stats will be. Let's see if that changes, if the time updates. Someone in here is for Brazil, right? No? No? I thought I had a student that was like hardcore Brazil. No, it must have been my other class. Okay, well, what do you say we start looking at the review? Yeah? Remember last time we took a test? We were supposed to take the test, and then at the end we were supposed to have a little bit of lecture, right? You're going to see how that works out. I do want us to try and get caught up a little bit because we've fallen behind. We'll be 3 sections behind if we don't do something on Thursday. But, it's not the end of the world, right? I just don't know how much brain I'm going to have left of yours, right, after the test. I'm afraid it will be completely wiped out. So let's at least plan to be here the whole time next time, just in case. And if you finish early, you might have to twiddle your thumbs for a little while while I let everyone else finish. So bring something to eat or bring your Game Boy. Who plays Game Boy? No one plays Game Boy anymore? That's the thing to do, man. I like the Game Boy. Okay, here we go. 10 questions. Your test will not be this long, all right? But I thought I'd give you a variety of things to look at. So what I'll do is I'm going to work through, I'll do the first 7 for sure right now because it's been a while since we've done those. Numbers 8, 9, and 10 are all rational functions which we've just been doing, so you may not need as much with that. So I might just do one of those or something. Okay, so here we are. Number 1, sketch. f of x equals -2 x plus 3 squared plus 7. Now, on this test, the instructions will say, use the steps that we were given in class to sketch the following graphs or sketch the following functions. So I expect you to follow the method. That means I expect your cheat sheet to somehow help you. If you just go and do this and then draw a picture and that's all you give me, I will not give you credit. You have to show me how you got each thing, all right? So what type of function is this that you're being asked to graph?
Isn't that one that I did? Oh, vertex.
Yes, you already have the vertex here. This was the first type of function we started studying after lines, which was quadratic, okay? And for quadratic functions could have been given to you in two different formats, right? Remember the two different formats? It could be f of x equals a x minus h squared plus k. The other format that it could have been given to you is ax squared plus bx plus c. I realize it's been a long time, but those are the two things that we have. Look, if I'm grading your test and you start using the steps for polynomial functions on this, I will count almost the entire thing off. Because I expect you to look at that and know that's quadratic. All right? Or if you start doing the steps for rational functions, that means you really have no clue what this function is, right? I mean, so there's an expectation here that you'll be able to identify what it is you're graphing. So we have quadratic, and it looks like this, doesn't it? So what were the steps to graph quadratic when it looked like this? What was the first step? See who has decent notes.
Oh, it's over.
11 minutes. Identify the form. Okay, so left and right. Well, hold on. Left and right behavior, that's polynomial. Up or down, right? Up or down. So the first step was, does it open up or down? What does this one do? Down? Why does this one open down? Because a equals -2, which is a negative number, right? So the way we identify, this is a quadratic. Quadratic are parabolas, right? It's this or this. That's it. So it's going to open down, so we know that. Second step, vertex. Okay, for the vertex, when it's given in this form, it's just hk, right? And h and k should just be staring at you. But there was one thing we had to be careful with. What was it? The h is opposite of what you see in here. Right? It's opposite of what you see. So if you see a +3, h will be what? -3. Now k is the number that's out here by itself. And in this problem, k, you don't have to worry about switching it. It's just 7. Questions? And what happens if you accidentally use +3? Your whole graph's off, right? Okay, what's our next step? Before x-intercepts. Determine how many there are, or if you have any. So we sketched it, right? We did a quick little sketch. My quick sketch looks like this. My vertex is at -3, +7. There's my vertex. And the graph opens which way? Down. So it's got to go like this and like this, which means I should have how many x-intercepts? I should have 2. So I do my quick sketch just to verify I do have x-intercepts. So I'm going to move on to the next step, which I believe is step 4, right? Is this step 4? What was 4 then? What was 3? Let me see. 3 was... Okay, sorry. This was 2. This was 3. This was 4. The first step was the form. Okay? First step was the form. And the form we had was ax minus h squared plus k. All right? Sorry about that. Thank you. All right, now fifth step, x-intercepts. How do we find the x-intercepts? Set the function to 0, right? Negative 2, x plus 3, squared plus 7 equals 0. Now, when you have it in this form, okay, when you have it in this form right here, the way that we solved this equation was kind of special. See if you remember this. We are going to try and get this by itself. So first I will subtract 7 from both sides. And that gives me negative 7. Then, I'm still trying to get this by itself. I did what? Divide by negative 2. Divide both sides by negative 2. All you're left with on the left is x plus 3 squared. On the right, unfortunately, 7 divided by 2 is not a nice number, is it? Negative divided by negative is positive. So what is that, 3.5? Is that 3.5? Okay, 3.5. I never gave you a problem like this on your, in class, I never did. We always had nice numbers, like this would be a 4 or something. Now what? Square root both sides. Square root, square root. When you take square root on both sides, you have to do what? Plus or minus, so plus or minus. Now what happens on the left side? The square and the square root cancel, so you just have x plus 3. But on the right side, you have to get on your calculator. And yes, you have to be able to take square root on this calculator. I mean, on this test. So I'm going to do the square root of 3.5. And I'm going to get 1.87083. What did I tell you about rounding in this class? Just like 1 decimal, right? 1 decimal point. So I would round this. You could round it to 1.8 or 1.9. I'm not going to get particular. My calculator is saying 1.87083. That's what I'm getting. I'm just going to say 1.9. Is that fair? Okay. So this side right here is plus or minus 1.9. Now, to get x by itself, what do I need to do? Subtract 3 on both sides. Now, be very careful in this step, because what you're going to do is you're going to leave plus or minus 1.9, and now you're going to subtract 3. All right, just took 3 away from both sides. This gives me 2 possible answers, doesn't it? One answer I get is when I do positive 1.9 and then take away 3. The other answer I get is when I do negative 1.9 and then take away 3. And those are 2 different answers, aren't they? The one up top is what? Negative 1.1. And the one on the bottom is negative 4.9? Yes? Okay. Those are my x-intercepts. Questions? Questions? What's the next step? Y-intercepts. That's step 6. Step 6, y-intercepts. To do that, we plug 0 into the function. So we had negative 2, it was x plus 3, so it's 0 plus 3 squared plus 7, right? So I'm replacing x with 0. What's 0 plus 3? 3. Square it. 9. You square that first, right? You don't do this multiplication. You square that first. 9 times 2, negative 2 is negative 18 plus 7. negative 11. And I think the final step is to draw it. So here we go. I have a vertex of negative 3, positive 7. I have an x-intercept of negative 1.1. So here's negative 1, right? Negative 1.1 is just a little bit further over, isn't it? Close enough? And then negative 4.9 would be almost negative 5. So here's negative 3, here's negative 4, here's negative 5. So right about there. And then y-intercept of negative 11. Remember our axis of symmetry? Remember that thing? Right down the center of the vertex. Our picture should be symmetric to that axis. And it does not look like a V, right? This has to look like a U, so it has to be curved up top. So I'm going to curve this thing like this. And then I'm going to do this side first because I have 2 points over here. That. And then try and get the same sort of picture on this side. There we go. That's it. Now, we'll take a vote here. How many of you would like me to do number 2 versus let you do 2 on your own as the review? So how many of you want me to do number 2 also? It's exactly the same, yeah. I mean, it's actually a little easier because you know how we got decimals here? On that one, you won't even get decimals. It'll be nice integers.
Like I did the last time where you made the video showing.
I don't know, man, if I'm going to be able to do that by Thursday. How about I just run through what the information is real quick? Like I'll put the information down, yeah? Let's see how quick I can do 2. Can I work fast? I'll work fast? Okay. Number 2.
It's 2, 0.
4x minus 2 squared minus 16. First step, it opens up because a is 4. Second step, the vertex is 2, 16. The third step is a quick sketch. Wait a minute. 2, negative 16. Oh, form. Form. Is this the form a x minus h squared plus k? Okay. It opens up. Vertex is 2 opposite of what I see, and then negative 16. That means it opens up. I will have 2 x-intercepts. To find them, I set the function equal to 0. Move 16 over. Divide by 4. Square root both sides. Add 2 both sides. Get my 2 answers, 4 and 0. This is all on video, so you can go back and pause, slow it down. Okay, next. Y-intercept, plug 0 in, is 4 times 0 minus 2 squared minus 16. Negative 2 squared is 4. Is that right? 4 squared, negative 2 squared is 4. 4 times 4, so we get 0, don't we? 0, not 6.
It's 3, 0. Jeremy's wife before.
It's 3-0.
At the 24-minute mark.
Wow. 3-0. So we can just turn that off. I guess we don't need that, do we? I think 3-0 is probably insurmountable. Well, they're only saying 2. Yeah, I trust you. That's good. I want to see Germany in the final. All right, so graph. My vertex was 2, -16. -16. My x-intercepts were 0 and 4. My y-intercept was 0. My axis of symmetry comes down here. It looks like a U. That. Like that. That good enough?
You just scored again, it's 4-0.
You sure you didn't you're not like on some crazy website where they're just
No,
pulling
no,
fast
no.
ones?
They had 5 shots at the goal and 4 of them gone in.
Wow. Okay, is this all right? I know I went through that quick, but do you think you could go back through that and watch the video if you needed to? Okay. All right, let's look at number 3. Number 3 is another quadratic function, isn't it? Now, you could also say that this is a polynomial. Because remember, all quadratics are polynomial. But if it's a quadratic, I expect you to use the steps for quadratic. So the steps for quadratic, again, what's the form? See, I remember this time. The form is ax squared plus bx plus c, right? Ax squared plus bx plus c. The second step, which way does it open? Down. Down y? A is negative, right? Then the vertex. And this is where things were different, right? For vertex, I need to find hk. But to get h, it's not obvious, but there was a formula for it. Negative b over 2a. That's how you get h. So what is negative b in this problem? What's negative b? Negative 8, right? Over 2 times what's a? Negative 2. So there's a negative 8 over negative 4. What's negative 8 divided by negative 4? Positive 2. So that's how you get h. How do you get k? Plug that into the function. F of h, so f of 2. So plug 2 into that and see what you get. So negative 2 times 2 squared plus 8 times 2 plus 3. So 4, negative 8,
11.
and then 16, negative 8, and 16, and then plus that. So you get 11. So your vertex is 211. There's going to be riots in Brazil today. That guy who hurt, what's his name? Neymar. Whoever hurt him, better go into hiding. All right. Got our vertex. Next step, quick sketch. My vertex was at 211. Up here somewhere, right? Opens down. I'm going to have 2 x-intercepts. I'm going to give you x-intercepts on the test, all right? But I'd still like to see you go through the steps. Step 5, what are the x-intercepts? So I take my function, negative 2x squared plus 8x plus 3, and I set that to 0. Now, how can you solve that quadratic right there? Quadratic formula will work. You could try factoring. This one's not going to factor. So you're going to have to use quadratic formula. So you better write that down on the test, quadratic formula. Remember what it is? That one, yeah. All that. So this for us will be -8 plus or minus b squared is 8 squared, that's 64, minus 4 times a, which is -2, times c, which is 3, all of that divided by 2 times a, which is -2. So you got to be able to plug all this in here and get an answer. I'm not going to go through that work. I'm just going to tell you what it is. We have 2 answers. If you are uncomfortable with how to get the answer out of this, I would go back and watch the video because I did do one in detail. You know, because you have to do plus or minus here and everything else. You should get from this, the 2 answers are -0.345, and then the other one is 4.345. So I can round that to 0.3 or -0.3 or I could even say -0.4 if I wanted to. This 4.3 or 4.4. Okay, so rounding wise. But those are my 2 answers. All right, I have my x-intercepts. Y-intercept, this was the easiest part of the whole thing, right? Y-intercept? Because what's the y-intercept when it's that one? 3. So step 6, I do f of 0, which gives me 3. And now graphy time. My vertex was 211. Is that what it was? 211? Was that a band? 311. Where are my x-intercepts? -0.3. Where's -0.3 here? Over here somewhere, right? Here's -1. -0.5 is halfway. -0.3, I don't know, somewhere around here? Is that good enough? The other one's at 4.3, so here's 3, here's 4, here's 5, so I don't know, around here. Do a quick little look at this. Do those look symmetric? Does it look like my x-intercepts are equally spaced? All right, distance from here to here is about distance from here to here. Happy with that. Y-intercept was 3. 1, 2, 3, that's here. And that should be everything I need to draw it. Nice U shape. That. Good enough. Okay, number 4 is exactly like number 3. So we'll vote, go through it or not? Is that yay or nay? Nay?
You can put on the Wolfram, and then we'll show you.
Yeah, if you just type that in, it'll give you everything.
So you can go ahead and check the work.
That's right. Yep. Yeah, if you type 3x squared minus 6x minus 7 into Wolfram Alpha, it'll give you the graph, it'll give you the factors, it'll give you the whole thing. So, it'll probably give you the vertex too. All right, moving along. Number 5. So now we're trying to sketch x to the 5th plus 8x to the 4th minus 5x cubed minus 84x squared. What type of function is this? I didn't give y'all a break, I'm sorry. Y'all doing okay? Okay. I'll let y'all go as soon as we agree we're done. What type of function is this? Polynomial, right? So polynomial, the set of steps for us were, number 1, left-right behavior. Is that correct? Does that seem right? Yes, left-right behavior. What does this one do?
So up and down.
Up and down? What does the left side do? What does the right side do? So remember that table I gave you?
Isn't it right up, right down?
It's this one. The degree of this, right? The degree is 5, which is odd. The leading coefficient, the number in front of it is 1, which is positive. What happens if you have an odd degree and a positive leading coefficient? It goes down on the left and up on the right. You all remember that table? I would write that table down if you don't have it memorized. So that's our left and right behavior. What's the second step? X-intercepts. How do we find x-intercepts? Set the function to 0, right? And when you set it to 0, the first thing you should do would be what? Before you do synthetic division, GCF, right? Do you have a GCF here? X squared, right? So pull your x squared out. 5, 0. X squared comes out. X cubed plus 8x squared minus 5x minus 84 equals 0. So I've pulled an x squared out, right? Do not forget about that x squared. We got to come back and take care of that later, right? But this piece in here is going to require some work to break it down. And what kind of work am I talking about? Synthetic division, right? You have to come up with that list of numbers and everything. So here we go. I'm looking at all the factors of what number? 84. Do I need to worry about the number in front? No, because it's a 1. And on the test, it'll be the same way. So what are all the factors of 84? Let's list them out. Well, we can have 1, positive and negative 1. We can have positive and negative 84. Does 2 go into 84? So you might want to break out your calculator. 2 goes in there. 42 times, right? Does 3 go in there? 3 goes in there 28 times? Is that right? Now what? 4? Does 4 go in there? 4 goes in there 21 times. 5? 6? 6. How many times? 14? I might run out of space. Thought I gave myself enough space. 7?
Yes, well,
7 goes in there 12 times. 8? 9? 10? 11? 12? We've met 12 already, haven't we? That's the list. It's a big list. Where do we start? 1. Now, in my synthetic division, I'm putting what numbers in there? 1, 8, negative 5, negative 84. Remember to account for any spaces, right? We don't have spaces in this one. Okay. Anybody doing this by hand? If you are, someone try negative 1 and someone try 2, because I want this to happen soon. 1, 1, 9, 9, negative 4. I mean, no, positive 4. Not even close. Negative 1. You got something?
No, 3 works.
3 works. Has anyone tried 2 or negative 2? No? Did you try 2 and negative? No, you just jumped to 3?
That works, so.
Okay. I'm going to go in the order that it would have appeared, so let me just make sure 2 and negative 2 doesn't work. That's not going to work. 3? So it took 5 tries, technically 5 tries, for it to work. Let's see. 1, 8, -5, -84, and 3 out here. Does everyone at least understand what I'm doing, though? Everyone's good with it? Okay. So 3 should work. 1 comes down, 3, 11, 33, 28. And we said 3 and 28 were factors, so yes, that's 84. And that gives me 0. So what does that tell me? I can use this 3 out here and write a factor of x minus 3. Remember, always opposite of the number, right? And then this piece gives me x to what power? Squared, then plus 11, x plus 28. And that you can either keep doing synthetic division or you can use AC method. I'm just going to assume you did one or the other and you got it, because that will break down to be what? X plus 7, x plus 4. So we have our final factored version. Is that it?
Yeah, the x squared.
Don't forget the x squared. Good. So our original function, the equation we're going to be solving, is going to be that x squared we had from the beginning, the GCF we pulled out, x minus 3, x plus 7, x plus 4 equals 0. And now what we do is we look at each of those and figure out where our x-intercepts are and if we cross or bounce there, right? So what about this one? What makes that 0? If x is what? 0. Will I cross or bounce there? Bounce, because squared, right? What makes that 0? 3, cross or bounce? Cross, because power is 1. Actually, all these are power 1 there, right? So the rest should be crossing. I'll cross at -7. I'll cross at -4. Picture time? Y-intercept? Did I tell you I'll get it Y-intercept? Is that one of the steps? It is? Okay, what's the Y-intercept of this function? Plug 0 into that function. What do you get? Should get 0. So Y-intercept of 0. All right, let's draw it. I have -7. -4, 0, and 3. Okay, those are my x-intercepts. My y-intercept is 0 also. My left and right hand behavior. Left side goes down, so from this point down, from this point up. And then I cross everywhere except 0, I bounce, right? So I come up here like this, draw it, I cross through, I bounce off 0, and then I come back and cross through. All right. Doing okay? Take a look at 6 quickly. Are there any questions? Does this seem like a lot of information, or does it seem like, just a couple of things you got to know? Or
There was a huge gap of activity, so it's kind of.
what do you mean? Oh, with all the break and stuff?
Yeah.
Yeah. The holiday? I hear you. Okay. Well. You weren't studying that whole time? What? Polynomial function, right? Left and right hand behavior. What's our left and right hand behavior?
Both going up.
Both up. Middle, I don't know. Second step, set it to 0. Do we have a GCF? Just X? So I'm going to pull that GCF now. And that's supposed to be equal to 0, right? This piece right here, right, that piece right there, I can use synthetic division on, can't I? But it's also 4 terms, isn't it? I could try grouping. It's just a question of if grouping works or not. I believe grouping does work, though, on this one. I don't know what you would do, what you would do during a test. If you go straight to synthetic, that's fine. But I want to show you this one with grouping, just so you see it. I could do that right there. What can I factor out of the first 2 here? X squared. What's left? X plus 5. And then this one has to be X plus 5 also. So what do I factor out of that one? Negative 4. Right? Then, since these match, I can write my X out here. Then I can write whatever matched. And then next to it, what? X squared minus 4. And all that equals 0, but that's a difference of squares. X squared minus 4 is X plus 2 times X minus 2. I just wanted to show you that to see how much faster that is than doing all the synthetic, although synthetic would still get you there. Because I'm there, right? I've got all the factors. Let's look at what these create for us. So this X right here creates a factor of what? Or an X-intercept of what? 0. Will I cross or balance there? Cross. This one, all of them are cross, right? They all first power? This one, negative 5. Cross. This one, negative 2. Cross. This one, positive 2. I cross. Crossing everywhere. Picture. Oh, y-intercept? 0 again. Okay. Picture. Negative 2. Negative 5. 0. 2. Up, up, right? Cross everywhere. Cross. 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 That wouldn't be wrong, would it? Okay. How about 7 for you, huh? You want to do 7 at home? 7 will not work. When you set 7 to 0 to get the x-intercepts, grouping won't work. Synthetic will be the only thing that works. So see if you can figure that one out. Would you like to just see the answer? Okay. Okay, x minus 4 minus 1 plus 3. I'm just going to give you the picture of what it should be. Y-intercept would be 12. That's what it would look like. Okay, how are we feeling? Lots of time left. All right, so why don't we do this? Number 8, right now, you do on your own or with each other. Do it on separate paper to turn in as a quiz grade, as a group activity. As soon as you're done with that, you're free to go. All right? Number 8. It's a rational function, so I want to see how y'all do. Feel free to move around if you want to join other people. You're each turning in your own. So you can join a group. If you don't like your group, you can move to a different table. All right. And I think that'll wrap it up. What have I not done? Just 9 and 10? Is that right? Okay, so I will provide the answers for 9 and 10. I'll put those out on the web for you so you can have them, all right? I'll probably email you the answer, the solutions.